Continuing on with lesson 3.5. In the second part, we'll look at a scalar multiplier. A scalar is simply a coefficient multiplied to each element in a matrix. For example, determine 4A, given that A is a matrix that has 2 rows and 3 columns. So matrix A is a 2 by 3. It's important to kind of practice that often to make sure you understand what represents the rows and then what represents the columns. Now, if we're multiplying with a scalar of 4, truly all that means is we're going to take 4 and multiply it to every element in this matrix, and that's all it is. So 4A would equal 4 times 2, which is 8. In row 1, column 2, 4 times negative 4 would be negative 16. And in column 3, 4 times 6 would be 24. In row 2, 4 times negative 1 would be negative 4. 4 times 0 would stay 0. And last but not least, row 2, column 3, 4 times 8 is 32. And that's it. A scalar multiplier just multiplies every element in the matrix by that number. Given matrices A, B, C, and D, perform the following operations. A is 2 rows, 3 columns. It's a 2 by 3. Notice B kind of flips that. There are 3 rows and 2 columns. Both C and D match the elements in A with 2 by 3 for both of them. If you're asked to add B plus C, order will matter as far as subtracting, but adding you could literally write them in either order. I like to stay consistent with how they're written. Matrix B is 6, 5, negative 2, 0, 3, and negative 4. But if we try to add matrix C to that, 12, 0, 0, and 0, 15, negative 9, the elements are going to end up getting stuck. Like we could match the 6 with the 12 and the 5 with the 0, but then there's nothing left for that last 0. So notice with a 3 by 2 and a 2 by 3, obviously the elements don't match. Therefore, this is not possible. You can't find a sum unless the dimensions, whoa, that's a lot of S's in possible. Sorry about that. All right, there we go. You can't add or subtract unless you have the exact same dimensions. Now over on the right, we're doing a combination of scalar multiplication and subtraction. Notice it says 2 times C minus 3 times D. If we think about C and D alone, they're both 2 by 3 matrices. So that means this subtraction problem is actually possible. I'm going to take matrix C and multiply everything by 2. So we're just going to double the value of the elements in that first matrix. 12 would become 24, and zeros would stay 0, so that's kind of nice to work with this one. In row 2, we get another 0, but then 30 and negative 18. So then it's minus 3D. What I'm going to do on this one is I'm actually going to take the negative 3 as my scalar, and then that'll change the operation in between to plus. You can do subtraction if you want, but oftentimes when you have subtraction, sometimes maybe we forget one, or if there's a negative on the inside, that can throw us off. So I like to throw that negative in with my scalar right away. Negative 3 times negative 5 would be positive 15. Negative 3 times 7, negative 21. And negative 3 times negative 3 would be positive 9. In row 2, negative 3 times negative 4, positive 12. Negative 3 times negative 8, positive 24. And last but not least, negative 3 times 2 would be 6. So order of operations, we performed the multiplication first, and now we'll add corresponding elements. 24 plus 15 is 39 for row 1, column 1 in each matrix. 0 minus 21 would be just minus 21. Nothing changes there. And then 0 plus 9 is 9. In row 2, do the same thing. Match up the corresponding elements and add. And you should end up with 12, 54, and Did I miss something? I did, didn't I? Oh, you guys. -3 times 2, I knew that didn't look right. That's -6 right there. And that would give us -24 when we add them. Well, I'm glad I caught that. And there's your subtraction matrix. And finally, use the given matrices to solve for x. Hint, capital X is going to represent a matrix when we're done. Given an equation with matrices as your capital letters, 2a plus x is equal to -4d. So in theory, we want to solve for this matrix x right here. To get x by itself, we'd need to move 2a over using subtraction. Ultimately, this just becomes another problem similar to the one we just did. To determine the values in the elements, or of the elements for matrix X, we need to perform the operations -4d minus 2a. So I'm going to let you guys try this one. Pause the video if you would, and write down -4d, create that new matrix with a scalar, and then -2a and combine them. When you're done, press play, and that will do it for lesson 3.5. When you're finished, you should have a 2x3 matrix, 10, -14, and 6 in row 1, and 8, 16, -4 in row 2. And that's lesson 3.5, working with matrices either adding and subtracting or multiplying by a scalar.